Hi guys, this is the final part of ISRO Space Application Center's Technician B Electronics Bar IT previous year questions and detailed solution. Up to part 5 we discussed in the last videos. So consider the question number 81. In measurement system, which of the following are undesirable static characteristics? Answer is option D, drift, static error, dead zone and non-linearity. Just look, what is drift? It is undesired gradual change of instrument output over a period of time which is unrelated to change in input, operating conditions or load. What is static error? Static errors are errors that don't change with respect to time. Next is dead zone. It is defined as the range within which the variable can vary without being detected. Non-linearity. Accuracy and linearity are related to each other, so it is better to keep non-linearity as small as possible. Question number 82. Following are not precision measuring instrument. Answer is option D, measuring tape. A precise measuring tool is one that can measure values in very small increments. For example, a standard ruler can measure length to the nearest millimeter, while a caliper can measure length to the nearest 0.01 millimeter. Examples of precision measuring tools are calipers, micrometers, bore gauges, adjustable parallels, height gauges, precision depth gauges, dial test indicators, durometers. Question number 83. Precision dimension measuring instruments measures at an accuracy better than. Answer is option C, 0.01 millimeter. A precise measuring tool is one that can measure values in very small increments. For example, a standard ruler can measure length to the nearest millimeter, while a caliper can measure length to the nearest 0.01 millimeter. Calipers measure dimensions of workpieces, parts or features for a variety of applications including quality assurance inspections. Micrometers perform outside inside depth or specialty measurement at a higher level of precision than calipers, other gauges and hand tools. Question number 84. Diamond is an insulator. Is answer option B. Diamond is a solid form of pure carbon with its atoms arranged in a crystal. The two most common allotropes of pure carbon are diamond and graphite. Diamond normally has a very wide band gap of 5.6 electron volt, meaning that it is strong electrical insulator that electrons do not move through readily. In a diamond, all the 4 electrons present in the outer shell on each carbon atoms are used in covalent bonding. So there are no delocalized electrons present and thus makes a diamond an insulator. Question number 85. In a neutral atom, the charge of proton is, answer is option B, 1.6 into 10 raised to minus 19 coulomb. When an atom has an equal number of electrons and protons, it has an equal number of negative, that is electrons, and positive electric charges, that is protons. As a result, the atom's total electric charge is 0 and it is said to be neutral. Therefore, all the elements in a periodic table are neutral atoms. Proton is the positively charged particle present in the nucleus of the atom. Charge of proton is 1.6022 into 10 raised to minus 19 coulomb. Question number 86. Closeness of instrument readings with each other is known as. Answer is option A, precision. Precision refers to the closeness of 2 or more measurements to each other. For example, if you weigh a given substance 5 times and get 3.2 kg each time, then your measurement is very precise. Precision is independent of accuracy. Note, what is accuracy? It is the closeness to the true value. Closeness with which an instrument reading approaches the true value or accepted value of the variable or quantity being measured. It is considered to be an indicator of the total error in the measurement without looking into the source of errors. What is resolution? It is the ability of the measurement system to detect and faithfully indicate small changes in the characteristic of the measurement result. The degree of fineness to which an instrument can be read is known as the resolution. What is conformity? It is the ability of an instrument to produce the same reading, or it is the degree of similarity between the individual measurements. So it is also called repeatability or reproducibility and the number of significant figures. Question number 87. According to Coulomb's law, the electrostatic force between two charges Q1 and Q2 coulomb separated by a distance d meter is given as. Answer is option A, Q1 Q2 divided by 4 pi epsilon d square. Just look, what is Coulomb's law? It states that the magnitude of the electrostatic force F between two point charges Q1 and Q2 is directly proportional to the product of the magnitudes of charges and inversely proportional to the square of the distance d between them. It is represented mathematically by F equal to K into Q1 Q2 divided by d square, where K equal to 1 by 4 pi epsilon. Question number 88. The prefix pico represents. Answer is option A, 10 raised to minus 12. Just look this note. The prefix and its meaning. Milli, M means 10 raised to minus 3. Micro, mu means 10 raised to minus 6. And nano, N means 10 raised to minus 9. And pico, P means 10 raised to minus 12. Question number 89. Resistance of conductor having resistivity ρ, cross-sectional area A and length L is measured by. Answer is option C, R equal to rho L by A. Resistivity ρ is an intrinsic property of a material independent of its shape or size. The resistance R of a uniform cylinder of length L of cross-sectional area A and made up of a material resistivity ρ, that is R equal to rho L by A. Resistance is proportional to resistivity and length and is inversely proportional to cross-sectional area. Question number 90. What is the color code of 10 ohm plus or minus 5 ohm resistor? Answer is option A, brown, black, black, gold. The color of the first band and second band indicate the value of the first and second significant bit. Therefore, the first band is brown, which corresponds to value 1, and the second band is black, which corresponds to the value 0. This is added to the right of the first digit from band 1. Therefore, the digits from band 1 and band 2 are 1, 0. The third color band represents a decimal multiplier by which the first two digit must be multiplied to obtain the resistance value of the resistor. Takes the digit and multiply them by a value given by this band. In this case, the third band is black, which corresponds to number 0. That is, no 0 multiplier to to get 10 ohm. The fourth band indicates the tolerance values. The gold band is used in this example, giving us the tolerance of 5%. This is the 4-band color code system. The first band, according to the color, black is 0, brown is 1, red is 2, orange is 3, yellow is 4, green is 5, blue is 6, violet is 7, grey is 8 and white is 9. For second band also, black has 0 value, brown has 1, red has 2, orange is 3, yellow is 4, green is 5, blue is 6, violet is 7, grey is 8, white is 9. For third band also, the multiplier with third band value is also black, same as first and second. The decimal multiplier is third one. Sorry, actually this is for the 4-band code system. Therefore, the third band present here. Normally, in our example, it's like first band, second band, third one is the decimal multiplier, which is corresponding to black. The decimal multiplier is 1. For brown, it is 10. Red is 1, 0, 0. Orange is 1, 000. For yellow, it is 1, 0, 000. Green, which is 1, 0, 0, 0, 0, 0. Likewise, the tolerance for brown is plus or minus 1% and for red it is plus or minus 2%. For gold the tolerance is plus or minus 5% and for silver it is plus or minus 10% and for none color the tolerance is plus or minus 20%. Also the decimal multiplier for gold is 0.1 and for silver it is 0.01. Consider question number 91. Quality factor Q of ideal coil is answer is option B infinity. Quality factor is a ratio of reactance to resistance. Then Q equal to X by R. Since Q is the measure of efficiency and an ideal capacitor would have an infinite value of Q, meaning that no energy is lost at all in the process of storing energy. The quality factor Q is defined as the ratio of the resonant frequency to the bandwidth. That is Q equal to FR by bandwidth. That is Q equal to resonant frequency by bandwidth. Question number 92. Inductive reactance of coil depends on answer is option C frequency of supply. The opposition offered by an inductor to the flow of alternating current through it is called the inductive reactance. Inductive reactance depends on two terms, that is frequency and the value of inductance. XL equal to 2 pi FL, where XL is the inductive reactance, F is the frequency and L is the inductance. The inductive reactance increases with either increase in inductance or increase in frequency. Hence the inductive reactance varies linearly with inductance and frequency. 93. When two inductors L1 and L2 in parallel, its equivalent inductance is, answer is option A L1 into L2 divided by L1 plus L2. That is inductors and resistors resistance and equivalent inductance are same. Inductors in parallel L1, L2, L3 up to infinity, that is Ln. 1 by L equivalent equal to 1 by L1 plus 1 by L2 up to 1 by Ln. Here two inductors L1 and L2 are in parallel. Therefore 1 by L equivalent equal to 1 by consider this example actually. 1 by L1 plus 1 by L2. That is L1 plus L2 divided by L1 into L2. Therefore L equivalent equal to L1 into L2 divided by L1 plus L2. That is not inductors in series. Then the total inductance in series can be found by simply adding together the individual inductance of the inductors. That is L equivalent equal to L1 plus L2 plus L3 up to Ln. Question number 94. A 3.5 digit multimeter can display up to, answer is option A 1999. 3.5 represent there are 3 full digits and 1/2 digit in the digital voltmeter. The full digit varies from 0 to 9 and a half digit varies from 0 to 1. Hence the maximum value will be 1999. Question number 95. What does FM means? Answer is option B frequency modulation. What is frequency modulation? Frequency modulation is a technique or a process of encoding information on a particular signal, that is analog or digital, by varying the carrier wave frequency in accordance with the frequency of the modulating wave. This we can identify from the figure given. The first one is the message signal and next one is the carrier signal. The frequency modulation is performing on the message signal according to the carrier signal. Question number 96. If 3 resistors of 1 ohm each are connected in parallel, the resultant resistance is, answer is option C 1 by 3 ohm. For parallel combination of n equal resistance R each, then equivalent resistance R equivalent equal to R by N. Given resistance value R equal to 1 ohm and a number of resistance N equal to 3. Therefore R equivalent equal to 1 by 3 ohm. Question number 97. 3 cell each of EMF 1.5 volt and internal resistance of 1 ohm are connected in parallel. The equivalent EMF is, answer is option A 1.5 volt. In parallel connection, all anodes are connected at 1 point and all cathodes are connected together at other point. Therefore equivalent EMF E equal to E1 by R1 plus E2 by R2 plus E3 by R3 divided by 1 by R1 plus 1 by R2 plus 1 by R3. Equivalent internal resistance R equal to 1 by 1 by R1 plus 1 by R2 plus 1 by R3. Given E1 equal to E2 equal to E3 equal to 1.5 volt. R1 equal to R2 equal to R3 equal to 1 ohm. Therefore, equivalent EMF E equal to substituting the given values, we get 1.5 by 1 plus 1.5 by 1 plus 1.5 by 1 divided by 1 by 1 plus 1 by 1 plus 1 by 1. That is 4.5 by 3. That is 1.5 volt. Note: if n identical cells are connected in parallel, equivalent EMF of the combination E equivalent equal to E and equivalent internal resistance R equivalent equal to R by N. Series connection. In series connection, anode of one cell is connected to the cathode of other cell and so on. If n identical cells are connected in series, equivalent EMF of the combination E equivalent equal to NE and equivalent internal resistance is NR. Question number 98. Peak voltage, that is VPK of sinusoidal waveform is 20 volt. The RMS voltage is, answer is option C, 20 by root 2 volt. For any voltage waveform, RMS voltage is the square root of the mean of voltage squared over a time period. Vrms equal to root of 1 by t. That is integral 0 to t v of t dt. For a sine wave with Vp as a peak voltage, the RMS voltage will be equal to Vp by root 2. Given peak voltage equal to 20 volt, RMS voltage equal to Vp by root 2, which is equal to 20 by root 2. Energy stored in a capacitor is calculated using the equation. Answer is option A, half CV square. Energy stored in a capacitor is electrical potential energy and it is thus related to the charge Q and voltage V on the capacitor. The capacitor starts with 0 voltage and gradually comes up to its full voltage as it is charged. The first charge placed on a capacitor experiences a change in voltage, that is delta V equal to 0. Since the capacitor has 0 voltage when uncharged, the final charge placed on a capacitor experiences delta V equal to V. Since the capacitor now has its full voltage V on it, the average voltage on the capacitor during the charging process is V by 2. And so the average voltage experienced by the full charge Q is V by 2. Thus the energy stored in a capacitor E cap is E cap equal to QV by 2, where Q is the charge on a capacitor with a voltage V applied. Note that the energy is not QV but QV by 2. Charge and voltage are related to the capacitance C of a capacitor by Q equal to CV, and so the expression for E cap can be algebraically manipulated into three equivalent expressions. E cap equal to QV by 2, which is equal to, we know that equation of Q equal to CV. Therefore, it changes to CV square by 2. Again, we are changing. We know that E cap here is Q square by 2C, where Q is the charge and V is the voltage on the capacitor C. The energy is in joules for and charge in coulombs, voltage in volts and capacitance in farads. The last question of this series and this video, final part is 101. Capacitor reactance Xc of a capacitor C, frequency f can be calculated as, answer is option B, 1 by 2 pi Fc. Capacitor reactance is defined as the resistance offered to the flow of current by the capacitor. It is denoted by Xc. The capacitor reactance is Xc, which is equal to 1 by omega C. We know that omega equal to 2 pi f. So substituting here, we get Xc equal to 1 by 2 pi Fc, where C is the capacitance and F is the supply frequency. Capacitive reactance is inversely proportional to the supply frequency, that is Xc directly proportional to 1 by F. If the frequency increases, the capacitive reactance decreases and vice versa. Thank you.